Welcome to our today's class as presented by your teacher Wambeye Marakia, and today our topic is differentiation. Differentiation. This topic is found in Form 4 in our syllabus as taught in Kenya. The prerequisite knowledge you need to have in order for you to tackle anything in this topic, you need to have the knowledge of calculation of the gradient or the rate of change on a line. And this is taught in Form 2. So you need this knowledge in order for you to be able to calculate the gradient of any given curve. So if you have a straight line, like the one we are having on the board here, if you want to calculate the change of that line, you have the gradient is given by change in y over change in x. And when you have, that's how we calculate the change of any given line. The curve given here is the curve of 2 points, P and Q, on the curve of y equals to x squared. Now, these 2 points, this one is x, will be, the gradient will be 9 minus 1 all over 3 minus 1. This one will give us 8 all over 2, and the gradient will be 4. So the gradient of this curve between point P and Q is 4. But we can also move on to calculate the gradient as we come towards point P. So we introduce another point. We can have another point here, and we call it Q1. Also, we have another point here, we call it Q2. And we have another point here called Q3. And we have some another points, Q4, as you come towards P, because you want to get this gradient of this curve at this given point. So we could say that the point here, the point Q1 is 2, so the point on the y-axis will be 4. And the point Q2 here, it is, we are coming closer. We are coming closer to point P here. So this one will be, say, 1.5. And the 1.5, then this one will be 2.25. Then as you are coming closer, you are introducing the points that are moving from Q. We have Q1, Q2, Q3, and Q4, which are coming very closer to our P, because you want to get that point there. So I'm going to draw for us a table, which is going to show the points, which, and also the change, all of the gradient. So what you realize is that as we introduce a new point here, point P, Q1, this point will be 2,4. Then the change in the value of y, in the value of change in x, will be 1, and change in y will be 3. So change in y over change in x will be 3. Also, we have another point, P, Q2. That point will be 1.2, and the Q point will be 1.2. 0.44. And you realize that this point, as you are changing, the change in x value will be 0.2, and the change in the y value will be 0.04. The change of y over change in x, which is the gradient, it will be 2.2. Then also, we have another point, B and Q3. This point is 1.1, and the Q point will be 1.1. The change in the x value will be 0.1, and the change in the y value will be 0.21. The change of y over change of x will be 2.1. Then we have another point we have picked again, which is PQ4, which is P equals to 1.01, and the other point will be 1.020 with other points. But now the change in x will be 0.01, and the change in y will be 0.021. So the change of y over change of x will be 2.01. The last point I've picked as we are moving closer to P is 1.01 and 1.0201. So the change in x will be 0.001, and the change in y will be 0.0020. So the change of y over change in x will be 2.001. What are we looking at here? As we are moving closer to P, the gradient has come to 2.1. Then as we move closer to P, the gradient is moving and is actually becoming closer to 2, because this one is 2.01. And as we move now closer to that point, it will be 2.001. So as we move towards P, the gradient of our curve is becoming constant squared. We have a point here, P, which is having x on the x coordinates and x squared on the y coordinate. And on the point Q, because we are introducing a small change we are calling h, we are going to have x plus h on the x coordinate, and we are having also x plus h squared on the y coordinate. Now, there is going to be a change now on the y axis, and the change that is going to be there on the y axis is going to be x plus h squared minus x squared. Let me repeat again so that we can have clarity here. We are going to introduce a small change in the on our curve. We don't have to have a very big change, because from our table we saw we were introducing changes there on the table. But this time round, we want to introduce a smaller change. And this smaller change from point P and Q, we are going to present that change by h. It's a very small change. We don't call it a very big change. And this change is a smaller change as you tend towards your final point Q there. Now this change, if we introduce this change here, our coordinates, our P coordinate will be x on the x coordinate and x squared on the y coordinate, while our Q coordinate will be x plus h on the x coordinate and x plus h squared on the y coordinate. Now the change will have been introduced along the y axis. In this, it will be x plus h squared minus x squared. Our graph, point PQ, we want now to get the change in terms of the point h, which we have introduced. So the change on the y will be x plus h squared minus x squared. Now, over h. I want us now to expand this x or plus y squared minus x squared. If we expanded this one, it will give us this. It will give us x squared plus 2hx plus h squared minus x squared over h. Now, collection of our like terms, we have x and x squared there going, and we will be left with 2hx plus h squared over h. Then when we factor out h, then we have h there and h there going, and it will leave us with 2x plus h there. Now, it's very important now we use this 2x plus h. Now, our value of h is tending to 0. The limit of h is tending to 0. So if this limit of h is tending to 0, then this h can be taken as 0. So we are going to remain with 2x. You have obtained is called a gradient function. 2x here equals to the gradient function. 2x is our gradient function, and it's very important in mathematics or in differentiation to remember our gradient function, because it's the one we are going to be using all the time, the gradient function, to calculate the gradient of a given point on any given curve. The equation was y equals to x squared. Now, it is a change. We are introducing a change in y-axis over the change in x-axis. So, the change in y-axis all over the change in x-axis, because it's a very small change. This very, very small change which we have introduced. This very small change which we are being introduced, we denote it by sigma. Sigma. This sigma. So we have a change in y, which is called sigma y, over the change. Because of a small change, we call it sigma x. dy over dx. So this one is a small change. You know, it denotes a very small change in y over a very small change in x. And if we have a function of a curve we have been given, for example, the curve we have been using, the curve of y equals to x squared. We can get this function without going through that elaborate, a long method. We have a way in which we can have to get this by just knowing the mathematical part, and you get it very fast. Y over sigma x. This one, we take this superscript there and we multiply it with this number here. So this superscript is 2. We multiply down here by that superscript and we subtract 1 from that superscript. I'll repeat again. We get to that superscript. We get to this superscript here, to x squared. So this superscript here, we bring it down here, which we bring it down there, and then we subtract from 1 from it. So if you are going to do it, you are going to get that this one is going to be 2 times x, and because we subtracted 1 here, it will be 1 there. And in mathematics, when it's number 1, we usually don't show it. So it's going to be 2x. So the gradient function here is going to be 2x. So you see, this was the long method, and we were trying to derive. We were trying to come up with a formula that could assist us to get the gradient function. So if we have been given the equation of a curve, you will be able to come up with a gradient function by using the differentiation method. Simply by just looking at the equation and differentiating it so that you can be able to get the gradient function. Find the gradient function of the following. Y equals to 4x squared. In this example, we have our dy over dx equals to, we said we take the superscript there and multiply it with the coefficient that is given here. So it is 2 times 4, which is what? 8. X 2 there, and we subtract 1 from that superscript. So it's going to be 8x as the gradient function which we are supposed to calculate. Another one is y equals to 2x squared plus 1. 2x squared plus 1. Here, the dy dx of this one will be, we go one by one. This one is 2 as a superscript, and the coefficient is 2. So we take this times this one, you're going to get 4x. But don't forget to subtract 1 from that, so that we remain with 1 there. And we have a 1 here, which is just a constant. It does not have any coefficient on it. So constants in differentiation do not have any effect, they are dropped. We do away with it, so that we remain with dy dx equals to 4x. So the gradient function for this equation, which is y equals to 2x squared plus 1, is going to be 4x. We're also given another question here, and we are told to find the gradient function of the line and also proceed to get the gradient of that curve at a point 2, 8. Find the gradient function of the curve y equals to x raised to 3. Then proceed to find the gradient function at point 2, 8. So we proceed by getting first of all the dy dx, which is equal to, we said this superscript will multiply down there, so that we have 3. Then we proceed and subtract 1 from that superscript, so that we have x. And when you subtract 1 from 3, you get 2. So the gradient function of our curve is 3x. But we have been told to get now the gradient at 2, 8. So at this point, the point we are interested in is the point on the x-axis, the x coordinate, and the x coordinate here is 3. So we are interested on this x coordinate, and it's the x coordinate which we are going to take and substitute into the gradient function, so that we can be able to get the gradient of the curve at that particular point. So this one is going to be 3, and this is the coordinate of x. So we have, where we have x, we are going to put 2. So we have 2, but this x is squared, we are going to square that one there. So we are going to have 3 times 4, and the answer will be 12. So the gradient of this curve at this particular point is 12. At this particular point, 2, 8 is 12, and that will have done some good work there. You are going to do this assignment, and you are going to be able, if it's possible, to send this assignment to me. And this is how it works. You take the phone and take the picture of the page you have done the assignment, then send that picture to me. I'll have to look at the assignment, and I will be able to return back the answers, or I'll mark your work and I'll be able to tell you with the comments if you have done the assignment correctly. Thank you very much. Let us meet in part 2 of this very topic.